So today I wanted to start with homework questions. So any issues anybody's come up with as you started to do probably mostly the CAD assignment. Um, and then we'll do revolve. This is going to be a really useful uh, command in Fusion. And then I'll talk about how to make orthographic drawings, like the ones that I, handed you last time to show you what the parts were. It used to be in classes like this, you would spend a lot of time actually, like not even that long ago, like actually learning how to draw these things with a ruler and stuff. But now it's pretty easy to get a CAD program to do these for you. Um, and then we'll talk about assemblies. And then that's the end of what we're going to go over with CAD. And then I'll go into a little bit. Whatever time we have left over today will be time that you can use to start thinking about the design project. So that's sort of what we're doing today. The first homework question I got was just about submitting stuff, and it's uh, seems kind of unnecessarily confusing how to submit parts from Fusion. Um, so let me show you how to do that. Okay. So I'll just pick out a part at random from one of my folders. So here are all my folders. Let's go to uh, this thing. Oop, there's nothing in that folder. Nothing in that folder. Okay, so let's do, this is a drawing PDF. This is a part. So let me do this wheel. So I'm going to open this first so that I'm go up here to the document thing. I clicked open, and I'm going to open this wheel part. And hopefully that'll pop up. I don't know. I'm having bad luck with parts. Let me find it. More recent one. Uh, so let me go to the one we did for the last example. So this time I'll open Box. And there it is. So now I have this part, and it's in the cloud, but I want to get it to my computer so that I can put it places. So I'm going to go to File, Upload. Actually, no, I'm not going to upload. I'm going to go to File and go to Export, because I need to make this into an F3D file in order to save it. So it suggests the same name that it had before, but you can see that the first thing that pops up is an F3D file. There's all these other options. Later on, when we're going to 3D print, we'll export to STL files, because that's what the 3D printer understands. But we want the F3D, so I'll stay with that. Click Export. And when it's done exporting, you'll see a line pop up here that says, do you want to basically refresh the documents, the files that are in this folder? So data in this folder has been updated. I want to refresh that. And now you can see that F3D file in your folder. Okay. This is still in the cloud, but now we've taken their proprietary file type and made an F3D file type. So now that, and you can see, it's a little hard to see, but it actually says F3D there. Oh, this, what we did was Box. So the one called Box that says F3D in this document type, that's the one that we want to share. Okay. And so now you can just click on this F3D file, double click on it. And it'll bring you to this environment that, so you can see that the file you're dealing with is box.f3d, the one you want. And now finally, after all these steps, it gives you this option to download it. Okay, so now you can just click on download. And once you do that, it's actually in your download folder. So now I can go to my my computer files and go to downloads, and you can see the last thing that's been downloaded is this. And now you can put that in D2L or email it or whatever. Okay. So so you'll be in the part that you want. You'll go to export it as an F3D file, then double click on that F3D file and download it. That's the process. Any questions about that? And so then to turn it in, you'll go to D2L. Go to assignments, and this will be the assignment for 6.2. So you go to that and just upload that file that you just created and is now in the download folder of your computer. There's no way to go directly from the cloud to an email or D2L or anything like that. You have to first get it onto your computer. Any other questions about the homework assignment? Yeah.
Is the homework that's assigned today, will that be due tomorrow night or next Monday?
Monday. Yep. So you have a lot of time to work on it. Anybody have any questions, difficulty with that rectangular array of holes, or did you sort of figure that out? I didn't specifically talk about it. I just talked about doing it in a line. Okay. Well, if you have any questions, you can email me or whatever. Or best send me a message on here. Okay, so what we are going to do today is I'm going to talk about the revolve tool. Then we're going to do orthographic drawings, assemblies, and the design project. For the revolve, so when is this revolve tool useful? So the basic idea of the revolve is you can use it anytime you have a part that's symmetric about an axis. So you can think of that as if you have a part where you could imagine walking around it in a circle, taking pictures of it, and every picture that you take looks the same, then that's an axis symmetric part. Another way to think of it is if you think of stuff you could make on a pottery wheel, like, you know what I'm talking about? The idea, the benefit of using a pottery wheel is that every point on the thing you're making at any given height is the same distance from the axis of rotation of the pottery wheel. And so you can just kind of hold your fingers in place, and your fingers, as this thing rotates around, will make this axis symmetric thing. So you can make very complicated looking shapes. You know, imagine crazy bowls and stuff like that. The key is just that it needs to be axis symmetric. And so the part that I'm going to do is going to be the axle and wheels for like a toy car. So I'm going to do something that's has a length like this, and then two little flanges that keep it from sliding out of the car's body, and then two wheels. And let's think about some dimensions for this. How fat do we want this toy car to be? Let's say we want this to be 2 inches. Let's say we want this diameter of this is going to be a circular flange. Let's say that we want the diameter here to be 0.5 inches. Let's say we want the diameter of the wheel to be 1 inch. And then thicknesses, let's make this 0.2 inches. We'll make this 0.05 inches. And then the distance between, I guess we have a couple more distances we need. Let's make this one 0.5 inches. And I guess that's the only thing left that we needed in order to come up with, to define this. In making this part also, yes?
What about height of the axle?
The height, that's going to be at the midpoint of this. So that'll be, the center of that axle will be, the thickness of it. Yeah, you're right. So we need the thickness. Let's call that 0.1. Okay, so I think now we're good. All right, so we're going to use a revolve tool to do this because this is symmetric about the axle itself. Everything here is circular. I'm just telling you that. You can't tell from that picture what those shapes are, but this is a circle, this is a circle, the axle is a circle. And then one other thing about this is I could make all 4 of these features, but notice that there's a mirror symmetry in the middle. So I can save myself a little effort by just making the half here, here, to here, and then doing a mirror command to make the other half. So that's the way I'm going to approach it. I'm going to use the revolve tool to make 1/2 of it, and then I'll use a mirror to get to the whole thing. Let me just print this out so I have it. And then everyone get into Fusion, and we can do, I'm going to make a new folder that's called car assembly. And I'm going to double click on car assembly so that we're working in that project. And I'll start a new document. And this is going to be a part design. And I'll close the one I was in, that box. And in order to do a revolve, instead of sketching the entire cross section, I'm just going to sketch 1/2 of it. And then we'll do that 1/2 of it a full 360 degrees. So what I'm going to draw is something like this. Okay. And when we do the 360-degree revolve, it's going to put this other half here. Okay, and so we're going to sketch this shape with the sketcher, the same one that we use for extrude. And then we're going to have to, and then we'll go to the revolve for that shape, and we'll have to tell the computer what the axis is we want to revolve it around. This shape would look different if we revolved it around a different axis. And then you'll see that that shape pops in there. Okay, so I'm going to go to the sketcher, choose a plane to draw this in. And now I'm going to use the line tool to draw this shape just line by line. And then we'll go back in and create the dimensions. So the line tool, I'm going to start at the origin. And there's my rough half shape. You have to make sure that it's all the way closed, that it connects back to its starting point. And all of these things are saying it recognizes that I want those to be 90 degrees. If those are wrong, if any of those assumptions are wrong of 90 degrees, you can click on it and hit delete, and then it won't assume that anymore. But we do want those to be 90-degree angles. And the next step is I need to go and make these dimensions. So this length, how long do I want this to be? Actually, I'm going to do other ones first, just so it doesn't go haywire. And so let's say first I want, I'm going to start by giving the thickness of that axle. So that was going to be the whole thickness. The diameter of the axle is 0.1. We're only doing half of that shape though. So this is going to be 0.05. And I guess it didn't make the assumption that these would be the same. So I have to also make this one a length of 0.05. Then the flange, this piece here, has a full diameter of 0.5, which means if I take the dimension that goes from the middle of the axle to here, that should be half of 0.5. So that should be 0.25. The thickness of it is 0.05. Then the distance that goes from the center of the axle to the edge of the wheel would be half of the diameter of that wheel. So that's going to be 0.5. And the width of the wheel, the thickness of the wheel, is 0.2. And now all we have left are these distances between the wheel and the flange, and then between the flange and the midpoint of the axle. So I'll do this one first. So this would be 0.5. Yeah. So this one is going to be 0.5. And then this one is going to be half of 2, so 1. And that should be my shape. Anybody have any questions about that or need time to catch up to where I am? So all I did there is I sketched out the shape that we're going to use for the revolve command. And when you're done with the sketch, you can click Finish Sketch. And if you want, you can go back to the home view. And so there's the shape that we're going to revolve.
Sketch one.
Yeah. So since I already made this sketch, it's down here in the feature bar, so I can right click there, go to Edit Sketch.
Zoom out a little bit more.
This way or
Yeah. Thank you.
yeah. And so if we were going to extrude this shape, we would highlight this shape and then go to the extrude thing. For the revolve, we're still going to highlight the shape that we want, the sketch that we want, but we're going to go to the revolve tool, which has a shortcut here. And since we already highlighted the sketch, you can see that the profile is already selected. But the next thing it wants us to select is the axis. Okay, so let's, depending on what axis we chose, we would get very different answers for this. Let me do a wrong one once. So so if I select the axis and go here and select this line, we get this crazy thing that doesn't look anything like what we want. So I'll cancel that, highlight the sketch, go to revolve, and the axis that we want is the middle of the axle. So I want this line to be the line that we're revolving around. And then it gives you some options. Do you want it to go a full 360 degrees, or you can do partial revolves too, like this. But we want to go a full 360 degrees. So all the way around. That's what we want. And so I'll click OK. And now you can see we have this shape that we want. It's half of an axle with one flange and one wheel. Anybody have any questions getting here? And now in order to make this a full axle with 2 flanges and 2 wheels, we want to do a mirror with this as the mirror plane. So in order to use the mirror command, I'm going to highlight the shape that we just made. So I'm going to highlight this whole revolve. And I'm going to go up here to create and go to mirror. And you can see we've already selected the feature. So under objects, it says we've already selected one. So that's good. We haven't selected the mirror plane yet. So I'm going to click on that and zoom in until I can highlight this face. And it shows me what it would look like if I clicked OK now. That's what we want. And so if you click OK, now this is our completed thing. And I'm going to save this. It's in the folder we created, car assembly, and I'm going to call this the axle and wheels. And now if you go back and look at your folder, this part is in there. Any questions about that? All right, so now we have to do the car body, and I'm going to tell you the stuff that we need for it, and then you can do the rest the way you want. So that was the revolve. But now we're going to make a car body so we can put these together as an assembly, to take these multiple parts and combine them into an assembly. So for the car body, what are we going to need? We're going to need, so from the side, we're going to need a length. And we're going to need holes for the axles to go through. So I'm going to put one here and one here. And let's decide on some distances. So we'll make the center of the axle 0.1 inches from the bottom of the car. And we'll make the distance from the front of the car to the center of the first hole. Let's make that 1 inch. And then between these two, we'll make that 2 inches. And then to the back, we'll make that 1/2 inch. And then what about the diameters of these holes? Well, the diameter of our axle is 0.1 inches. So I need to make the diameters of these at least 0.1 inches. We're going to see, I'm going to bring this up when we start getting into the design project, but 1 millimeter is a pretty useful thing to keep in mind for clearances and for minimum thicknesses of things that we get out of the 3D printer. And 1 millimeter is, so they're 25.4 millimeters in an inch. So 1 millimeter is 1 divided by 25.4 inches. And so that's about 0.04 inches. So we're going to make a clearance of 1 millimeter for this hole. Anytime if you 3D print something, if you don't leave a clearance of right around a millimeter, it's not going to move. Things are going to catch on little imperfections and things. So I am going to make the diameter of each of these 0.14 inches. Okay, so that's the diameter of the axle plus that extra clearance that you need. So this is a side view. And then what about the front view? We have to fit the car body inside those 2 flanges that we made for the axle. So from the front, the hole is going to go through the body like this. And what matters is that this be somewhere around that 2 inches that we have between the 2 flanges. But we want to give it a little bit of clearance. Otherwise, those will press against the body and not spin. So again, I'm going to give this 1 millimeter of clearance. You could give it a millimeter on both sides, or probably a millimeter total is fine. So I'm going to go 2 inches minus 0.04, or 1.96 inches. Okay. And then what about the top of the car? Well, you can decide what you want that to look like. You can make it simple or whatever. But just make a car body where the bottom has something like this. Okay. So let's take, we'll try 15 minutes to start and see where everyone's at. But everybody just go ahead and work on this shape. And I'll make one for myself up here too. And we're going to save it into that same folder as car body. Here, I can print these out for everyone. Front and one in the back. Before we get into the assembly, I want to show you how to do dimensions on these things, to do orthographic drawings with dimensions. So if you haven't saved this, go to the save icon up here on the top. And well, for me, I've already saved it, but the first time you do it, it'll make sure that you're putting it in the right project. And we want that in the car assembly project. And you can save it. And now if you go to your folder tree, you should see both of these 2 parts in here. We only have, notice that we only have 1 axle wheel combination. We're going to need 2 of them, but that's okay for the assembly. We can just bring it into the assembly multiple times. Okay. And so let's do, because it's a simpler part, let's go back to the axle and wheel. So once you've saved it, you can close out of this. And you can go back to the file and open the axle and wheels. And now we're going to make a new document. So go to the document thing and say new. And it gives you all these choices. So far, the only things that we've done are parts. This time we want to do a drawing. So highlight the drawing and go to create new, and it's going to ask you some questions. We don't want to do an automatic one. We want to make it ourselves so we have a little more control over it. So go to manual. And you can choose the size of sheet you want, a few things like that. And everything else is good. So I'll click OK. And it's going to warn me that my resolution isn't right, but it'll work even with this. So you can just click OK and it'll do it. And it has to think for a minute. And it starts out by giving you, by choosing one view of your part and letting you place it somewhere. I don't want to do that. I want to do it on my own. So I'm going to cancel this. And so now we just have this blank drawing. And it's blank, but it has this thing at the bottom that makes it easy for you to fill things out about this part. For me, we don't have to use that for now. So I'm just going to highlight this and hit delete and get rid of that so we have more space to work with. And now we have to think about what view we want to put in our main position. So whatever we put in this main top position, it's going to be perpendicular to that we put down here and perpendicular to that in the other dimension that we put over here. So we want to make a smart choice about which one we put here. We happen to be doing a symmetric part. So two of these views will look the same. It's kind of redundant. Really, if you're doing a symmetric part, you don't have to do all three, but I'm gonna put all three in. So I think for me, what I would like to have in this main diagonal position is the front view like this. That's going to let us put the most dimensions on things. And so I'm going to if you pull this drop down menu, I'm going to make the base view. And I guess for now, this isn't the view I want, but I'll just place it here so I can go over and look at this drop down menu. So it gave me the wrong thing. It made it too small. And I'd rather see it in a wireframe view than in this three-dimensional view. So I'm going to change some of those things. So for the orientation, I'm going to see what the top looks like. Okay. If I click on, in orientation, if I click on right or left, that's the view that I want to see. So you can just click through those until it gives you the view that you want. And then for the scale, it's giving me a scale that that on the drawing is half the size of the actual shape. I would like to go bigger, so I'm going to try 1:1. And that's a little better, but I could fit even bigger on here. So I'm going to go 1 to 0.7. Try that. And that's a little more like it. Okay, so I'm going to stay at 1 to 0.6. You could also do that as, that would be the same as like 1.8 to 1 or something. And then for the style, I want to change it to, well, I would like to have my visible edges be dark. And then my hidden edges, I'd still like to show those in the picture, but I'd like those to be dotted lines. So I'm going to choose this one, visible and hidden edges. And everything else is fine. So I'm going to click OK. And that is what I want it to look like. And you can drag it over into position. And now based on this, I can do my projections. So if I project from here and rotate 90 degrees, I think it's going to do it around the axle. We're going to get a shape that looks just like this down here, which is kind of unnecessary, but we'll put it down there. Then when we project it this way, I think this is the one when it'll rotate it around that center line. And so what we're going to see is the outside of the wheel with dotted lines showing the outside of the flange and the outside of the axle. Okay. So I'll go pull this down here. And that's the one that isn't too useful. And then I'll go over here. And you can see we have those 3 perpendicular shapes. Can you visualize what I'm talking about here? These are perpendicular to each other. They just look exactly the same because this thing is symmetric about that axis. And now we can start thinking about what dimensions we need. So the point of a drawing like this is that you could send it to like a manufacturing shop or something to make this for you. Or if you're working on a big assembly with other people, you can send them this so they know what their parts need to, the restrictions on their parts so that it interacts with this the way you want it to. So I'm going to start by defining all of the distances horizontally. And the way you're told to do this is to have all your dimensions on the inside of the picture. So we're not going to put any dimensions if we can help it up above this thing or to the left of it. We're going to have them all down and to the right. So go over here to the dimensions tool and click on dimension. And we're just going to start putting these dimensions in here. And you can drag them so they look nice. And so now I'm trying to get it to recognize the length of this whole bar between the flanges, but it only recognizes the two halves. So you can also measure between two lines by clicking both of them. So I'll go here to here, and then that gives me that whole measurement. And I'm going to assume that it makes sense to whoever's looking at this that since it looks symmetric and I'm only giving measurements for one half of this thing, that they know that the other things have those same measurements. So all I have left is I've given all the horizontal distances. I have to give the diameter of this and the diameter of this. And so I'll go. It lets me select that whole line, it looks like. So I'll do that. And that. And now I think in this case, I didn't have to use any other views for it at all. Most of the time you have to show some of these things on the various views. You could also show, that this, you could show the diameter over here like this and the diameter of this. That's kind of redundant information, but it connects those two. Anybody have any questions about that? And then usually I also like to, I think most people like to have sort of a blown up three-dimensional image in the leftover fourth corner. So I'm going to take this, I'm going to do a projected view and just give a diagonal thing like that. And I'm going to make it a little bigger than the other ones. And this time I'm going to do this one with a three-dimensional view instead of a wireframe view, so you get sort of a realistic picture of it. And I'm never going to put any dimensions on that one. But there it is. And we're going to save this to the same folder. So you can go to the save icon. I haven't saved it yet, so it suggests a name, which is fine for me. It says the location is in the right project, so that's good. I'll click save. And now if you go back to the project folder view, once it's done thinking, it'll give me that warning or whatever, that alert again that something has changed inside this folder. Oh, it didn't this time. It's just already there. So this is the axle and wheels drawing. And now this is something that you would often, there'll be times when you'll want to put this in reports and things for this class. And so if you want to do that, well, one thing you can do is use the snipping tool and just take a shot of the screen to put into your document. Another thing you can do is upload, no, export is what we want here. So if you go to this export thing, it'll give you the option of saving this as a PDF. And that's what we want. So I went to export, created a PDF. When I refresh, that PDF is there. And now I can get it onto my computer the same way that we did with the F3D files. So I can go to the PDF, double click on it, download it. And now when I open that, it's just a regular PDF file. Okay. Any questions about that? All right, the last thing we're going to do today is we're going to make an assembly out of these parts that we have. So let's see. We have saved everything. So I'm going to close these. And now I'm going to make a new document. So go up here and create a new document. But this time our document is going to be an assembly. You can think of it as like, this isn't going to have any new parts in it. It's just going to be the way we arrange the parts with each other. So I'll go to Assembly Design and create new. And the pieces that go in an assembly are called, when we make those individual things, they're called parts, okay? But what you put in an assembly is called components. So we have to bring these parts in as components of the assembly. And so I'm going to go, I guess I'll give myself more space, close that folder view. And I'm going to first insert sort of my base component, which to me is going to be the car body. That's going to be what I base everything on. And so it's thinking of eventually it'll bring it in here. And it lets you move it around if you want. For that base part, that base component, there's not usually, I can't think of any reason that you need to move it around. All that matters really is how the other things relate to it. But if you want to view it in a different way, you know, you could rotate it, drag it around these things. It gives you every rotation option. So I'm going to click OK. And now that component is in there, and I'm going to insert a new component. And this time I'm going to insert the axle and wheels. And all you're doing here, you're not positioning it. You're not trying to put it inside the assembly yet. You're not trying to create a joint with the car yet. You're just trying to put it in a place where you can have access to see the different things that you need. So this is fine with me. But now the key thing is we're going to make the joint. We're going to make the connection between these two pieces. And so I'm going to go up here to motion. Nope. relationships. And I'm going to choose joint. So this is where we connect this is kind of the key thing for assemblies. And these wheels are kind of comically big for this car body, but what are you going to do? Well, so if you go first to motion, there's a few types of connections we could have. We could have these rigidly fixed together. Sometimes you want that. In our case, we want the wheels to rotate the axle to rotate freely in there. So I'm going to use this drop down menu and go to Revolute. And now I want to specify what things make contact, or, the relationship between a point on one thing and a point on the other thing. So for my first component, this is a little backwards of what you would think, but my first component is going to be the thing that moves. My second component is going to be the base. So my first component, I'm going to select the axle and wheels. Come on. Oh, and I guess I need to choose the point that I want. And I'm going to, so what I want is for this point here to be just slightly offset from this point here in this hole. And so those are the two things I'm going to use to define this relationship. So I'm going to go over here, zoom in so I can see it clearly. And I'm going to specify the center of the axle right at the inside of the flange. Okay. And you have to be a little careful because there's all these different points it's asking you if you want to reference. But I want the one right on the inside of the flange, right at the center of the axle. So that's the point I want. And now for component 2, it says, okay, what do you want to interact with that? And I want the center of the hole right flush with the car body. So I want this point. And then there's one more thing I want. I gave it that 0.04 inches of wiggle room. So I want each one of these flanges to be 0.02 inches away from the outside of the car. So I am going to, so I want it to go out this way, a distance of 0.02. And now if I zoom out, you can see I accidentally made like a monster truck. But you can see that there's this little bit of, just tiny little bit of wiggle room between the flange and the car body. Another thing you can see that's sometimes helpful is if you go back in to edit that joint, so go back in here to edit and go to back to the motion tab. You can preview the motion and it'll show the rotation that's happening. Oh, I got a little wobble, which means this is one of the things that's showing the motion here can help you see. I must have connected the wrong point to I either connected the wrong points to each other, or I did my offset along the wrong axis. That's why you're getting this wobble. What you should see here is just these reference axes rotating around and everything else looking consistent. So I'm gonna put the other axle and wheels in, and then that'll be it for today. And when I put the other one in, I'll just try to be more careful about not, if you're really doing this and you need it to be right, you would delete that joint, go back and redo it. But since we have two that are identical, I'm just gonna redo the old one. Yeah. Let's see. And I'll bring in the axle and wheels as the second component. And I'll rotate it and move it so I can access everything. And then I'll go to relationships, joints. And the first thing I want is this point. The second thing I want is this point. And this time I'm going to be a little more careful with my offset because I think maybe that's what I messed up last time. So I want it to be offset in this direction. And I want that to be, so that's the Z direction, the negative Z direction, and I want it to be a total of 0.02. And now if I check this motion, that's actually a glitch in this program. That's not me making that mistake. Holy moly. Okay, let's try doing this. Going back into edit. See what the motion looks like. Just because what? Oh, yeah, you're right, I'll bet. Okay, let's try that again. So preview motion. And now you can see it's going nice and smooth this time because I think last time I offset it from the center line and so it was wobbling. And now we would put the other one in and then it's ready for monster trucking. Clearly we should have chosen some of these dimensions differently. Okay, so cancel that, click out of that. And now you would just do the same thing for the second one. You can put in the same, we're going to insert the same component for the back. Let's see. So I'll get this in roughly the right orientation. I think getting it slightly close to the right orientation before you start doing the joint definitions can help the program figure out what you're trying to get it to do sometimes. So okay, now I'm going to go to joints. I'm going to choose this point. And I'm going to match that up with this. And it guessed at what I was trying to do correctly. And then I want to offset it 0.02 in the negative z direction. And make sure it's revolute this time. And preview the motion. And you can see it's going nice and smooth. That's a ridiculous looking car. But now this is something that we could take these parts, put them in the 3D printer. We can actually print it as an assembly like this. So because there wouldn't be any way to put these in with those big flanges there, but we could have it print this way. And when it comes out, this thing the wheels would rotate and everything would be the way we want it. It's pretty powerful thing for prototyping and I'm going to remember to save it this time. So now we have our finished assembly as a file. Anybody have any questions about that? Okay, well, that's the last we're going to do in class of CAD stuff. I'm going to give you some more CAD stuff to work on just to solidify these ideas. And then we're also now, for the assignment that's going to be due on Monday, I'm going to have you start thinking about this design project. So, okay. See you on Monday.